about the geometric sequence. And remember last time we talked about the arithmetic sequence, so now we are going to talk about the geometric sequence. Now the geometric sequence is a pattern and in this pattern the difference is now we don't have a common difference. Now if you look at the 3 and the 9, the difference is 6. The 27 and the 9, the difference is 16. And it's actually 18. And when you now want to look at the sequences, you can see that there's no common difference. And even if you go to the second difference, for those of you who know a quadratic sequence, there is not going to be a second constant difference. So here a geometric sequence would primarily deal with ratios, and just like we did with an arithmetic sequence, when we are finding our ratio we must do it twice. So the ratio is equal to T2 divided by T1, or it's equal to T3 divided by T2. And if I work out this ratio, then this will be 9 divided by 3, which is equal to 3. And this one would also be 27 divided by 9, which is equal to 3. So you can clearly see that I took my T, this is my T1, T2, and T3. So I took my T1, T2 there, and I divided it by T1 there, which is, I substituted for T2 with 9, and T1 with 3. 9 divided by 3 will then give us 3. And then now I went on to verify using the next ratio, which is also going to be T3 divided by T2, where T3 is 27 and T2 is 9. So 27 divided by 9 is also equal to 3. Then this would then confirm that it's a geometric sequence. Now this is the simplest version. Now let's look at another one where we've got, instead of us having whole numbers, we can have a different pattern. Let's say 1 over 2, 1 over 4, 1 over 8, and 1 over 16. Now this is another geometric pattern, and again remember what we said. When we want to find the ratio, we say T2 divided by T1, and T1 there, and R is equal to T3 divided by T2. And when we substitute, we're going to get R is equal to T2 is now 1 over 4 divided by T1, which is 1 over 2. Now you must be very careful now, because now when you divide, you are now going to see that if you take your calculator, you punch your calculator directly, the values on your calculator, you will see that 1/4 on your calculator divided by 1/2. You don't have to work it out laboriously. You just punch your calculator and you'll get 1 over 2. And then we also come to this side, we work out the second one. T3 is 1 over 8 and divided by T2, which is also 1 over 4. And when I divide this one, I will also get 1 over 2. Then this is also a geometric sequence. Now, I deliberately gave you two different sequences, but what I would want you to notice is that of the two sequences I've given you, they are both geometric. We've confirmed that. But remember, this one, the first one was 3, 9, 27, and 81, versus the second one, which was 1 over 2, 1 over 4, 1 over 8, and 1 over 16. Now, if you look at these two ratios, these two sequences, you notice that the first one has got a ratio which is 3. The second one has got a ratio which is 1 over 2. Now, if I keep going with both sequences, for instance, if I take the one with 3, 9, 27, the numbers will increase. So we start from 3, then we go to 9, we go to 27. The numbers get bigger and bigger and bigger. So they will not stop getting bigger. This is called a diverging sequence. So because the numbers are getting bigger, I'm just going to highlight that the numbers are going to get bigger there. This is called a diverging sequence. A diverging sequence is one where the numbers keep going apart, growing apart, and they are never going to emerge and come together. So they get bigger until they get to infinity. This is because our R is not a fraction. So in other words, it's not a number in between. So we're going to just say not. So we're going to cancel the not there by saying R is not there. Can you see I've just used those lines? Maybe I should do it clearly here. We just cancel that to say R is not a fraction, which means it's not a negative fraction or a positive fraction, a fraction between -1 and 1. But if we look at now the other sequence, the other sequence is half, then 1/4. This sequence is getting smaller. If you take your calculator, by the time you start from 0,5, the next one is 0,25. The next one is 0,125. This sequence will be getting smaller and smaller until a point that you will actually register it and it will become 0. Which means that our sequence is converging. It's coming towards one number. If you keep going, you end up getting the same number, which in this case is going to be equal to what? 0. So in this case, this sequence is converging, and that sequence is coming together. All the numbers are going to become 0. So if you keep going, you end up just getting 0, 0, 0, 0, 0. So the reason why this is happening is because our R is actually a number which is a fraction, and for us to write that R is a fraction, we say that our R is in between -1 and 1, which means that the sequence is diverging. So that is what we were looking at today. So we have seen what a geometric sequence is, and we have gone further to classify a geometric sequence, whether it's converging or it's diverging.